Okay. Raviraj, welcome again to our learning of engineering mechanics.
Yes.
In fact, now Lami's theorem, parallelogram law, and other things we have already studied to some extent.
Yes, sir.
Today we will discuss something related to beams. You all might have studied beams or seen beams. You always live in a house, you have beams going right across. You travel over bridges, that's also a big beam. So beams are an integral part of our life. But when it comes to design, how the beam is designed, then you require a little bit of mathematics, a little bit of basic concepts. And once these are known, solving problems related to beams is much, much easier. And today, Raviraj is there to help you to solve these particular problems in a very lucid and simple manner. Raviraj, are you ready?
Yes, sir.
Okay. The first question. Calculate the degree of static indeterminacy for the beam shown. You have a beam AB. It is with a hinge support here and with a roller support here. Your options are option A, 0, option B, 1, option C, 2, and option D, 3. Raviraj, you
Yes, sir. Degree of static indeterminacy can be calculated as the formula is dSi is equal to R minus E, where R is number of reactions and E is number of equations. Now R is nothing but the number of reactions. So hinge support will give you two reactions, one vertical reaction and one horizontal reaction. You can say it as HA and VA. The reactions are nothing but the constraints. So if you have hinge support over here, it cannot move in X direction, it cannot move in Y direction. So it is having two constraints, X and Y, therefore the reactions are 2. Whereas the roller support, it is having only one constraint, it cannot move in vertical direction, it can move in horizontal direction since it is having a roller. Therefore it is having a constraint in Y direction, so it will give you one reaction in vertical direction. Therefore number of reaction for this particular beam AB will be R is equal to 1, 2 and 3. Whereas number of equations, since this is a equilibrium concept, for equations of equilibrium are summation fx is equal to 0, summation of fy is equal to 0, and summation moment at fixed end equal to 0. So we have equations of equilibrium, number of equations are 3, therefore dSi is equal to 3 minus 3, 0. So the correct answer will be A, 0.
So Raviraj, you are opting for option A.
Yes, sir.
That's 0.
Yes.
After explaining all this, I think so your answer should be perfectly right.
Yes, sir.
And yes, it is the perfectly right answer. Option A, the degree of static indeterminacy of beam. Okay,
Yes.
Raviraj, can we go down to the next problem?
Yes, sir.
Okay. The next problem is, what is the type of static determinacy of the beam shown A and B? This is one fixed support, the other one is also at A is a fixed support. Option A, statically determinate beam, statically indeterminate beam. Option C, statically unstable beam. And option D, none of these. Can you, Raviraj, explain in brief what could be the answer of this question?
For solving such type of questions, we have to calculate first the number of reactions, right? So the fixed support will give you the 3 reactions. So it is having constraint in 3 directions. First will be in vertical direction, vertical reaction at A. Second will be horizontal direction, horizontal reaction at A. So in addition to that, there will be a constraint to movement also. So there are 3 reactions which are there at A. Same is the condition for B. So vertical reaction at B, horizontal reaction at B, and in addition to that there will be a movement at B. So reactions are nothing but number of constraints. So number of constraints at A are 3, at B are 3. So R will be equal to 6. Now number of equations for equilibrium are not going to be changed. They are remaining same. These are nothing but summation fx0, summation fy0, and summation movement at the fixed support equal to 0. Therefore, 3 number of equations are there. So E is equal to 3. So R is greater than E. Therefore, this is considered to be statically indeterminate beam. So correct answer will be, I think, statically indeterminate beam. B is the correct answer.
So Raviraj, you would say that statically indeterminate beam is the correct answer. And you tried to explain that you had these 3 equations which need to be solved. So equations are 3. Reactions which you calculated are 1, 2, 3 on this at point B. Similarly 1, 2 and 3 at this side of beam. So you have total 6 reactions which are there. So as R is greater than 3, means whatever equations which are necessary to solve, the reactions are much more.
Yes, sir.
So automatically you are not able to
Solve.
these particular problems.
Yes, sir.
So you are saying that it is statically indeterminate beam.
Yes, sir.
So from engineering mechanics point of view, I would understand, but these types of beams are always there. If I see in a room, they are always fixed. So how would you solve these type of problems?
There are various methods by which you can solve such type of problems. So we need additional 3 equations.
Okay.
So that number of equations will be 6. Number of reactions will be 6.
Okay.
Therefore you can solve it. So there are various matrix methods are there from which you can solve such type of beams, right? So therefore you can use such type of methods to solve such type of beams. So you need 3 extra equations so that you can solve this type of beams.
So in our basic engineering mechanics, we will define this as an indeterminate structure.
Yes, sir.
But it is not physically indeterminate.
Yes.
You can solve these particular equations maybe using the matrix methods, or maybe sometimes, what could that be? Finite element?
Finite element method, finite analysis
Okay.
methods.
But these are at a much higher level.
Higher level. In
So for
third
the
year B level you can
Third year B and the other part. So you have to study much more of mathematics further, and then you will be able to solve these type of problems. Okay? Till then, for this particular situation, it is an indeterminate beam. So option B is the correct answer. Okay, Raviraj, that's really fine.
Sir, I have to explain the remaining 2 options, which are statically determinate beam and statically unstable beams.
Okay.
So that
in fact, you very nicely posed the question correctly. In fact, I was to ask you
Yes.
as to why have you selected this answer.
Yes, sir.
Can you explain why these answer is correct?
If such condition is there, it is definitely R is greater than E, statically indeterminate structure. But if such condition is there, for example, the last example we have solved, which is having the hinge support at A and B roller at B. So as we have calculated the 2 reactions at A, HA, VA, and 1 reaction at B, reactions are nothing but the constraint. So R is nothing but equal to 3. And number of equations again going to be same, fx0, fy0, summation movement at fixed point is equal to 0. Therefore, 3. So number of equations will be 3, number of reactions will be 3. Therefore, R is equal to E. That is, number of reactions is equal to number of equations. So it is statically determinate structure. Whereas the third options we have posed, that is statically unstable structure. So such type of condition is there. If we have roller at A and again roller at B, therefore it will give 2 reactions, one at vertical reaction at A, vertical reaction at B. Reactions are nothing but constraints. So R is equal to 2 in such condition, and E is going to be constant for equilibrium, which will be 3. Therefore R over here is less than E. such type of beam or such type of structure is called as statically unstable structure. So we cannot stabilize it. You can see this is having not any constraint in x direction. It can move in x direction. This is also can move in x direction. It is having constraint in y direction. So it is a statically unstable.
It is just like roller skates, na?
Yes, sir.
So your roller skates, you have the fixed wheels at the lower end, and maybe wherever you keep your foot is just like a beam.
Yes, sir.
So you can move.
Yes.
But if you are not balanced properly,
You might be sick.
you might be falling around.
Yes.
I think so. You like playing roller skates,
Yes.
maybe in your childhood days.
Yes.
I don't know whether you are playing it now or not, but children like to play roller skates, so it
Yes.
will be an important part. You have to explain one more thing. None of these is not a question.
Yes, sir.
So E is equal to 3 is statically determinate structure.
R is equal to A.
Sorry, R is equal to 3 is
statically
determinate
determinate
structure.
structure. R is greater than
greater
E,
than 3 indeterminate
indeterminate,
structure.
and R is less than E is unstable.
Unstable structure.
So
Okay.
we have solved 3 questions actually in this particular question.
You have given me 3 answers
Yes.
for and why the other thing is not to be there.
Yes, sir.
Raviraj, I think so that's a great learning for me also.
Yes.
Okay?
Yes, sir.